Ladies and gentlemen, I am Wenjie Wan, the first author of this presentation. We have developed hardware and software of MT array, which has been used in Taiwan, Japan, China, and Philippines. Today, I would like to present you our MT array exploration results compared with drillings in Taiwan. The contents of today's presentation are: first, I will show the advantage of MT array exploration. Second, I will show the MT array results at Hongzhilin area northeast of Taiwan. Third, is our MT results at Chipen Taidong, eastern part of Taiwan. Fourth, is the third comparison in Datun volcanic area around Jinshan No. 1 geothermal well, drilled by Chinese Petroleum Corporation. The last would be our conclusion. For array data acquisition, we use at least 3 simultaneously recording stations for stacking and to identify the uncorrelated noise using variance techniques and Wiener filter to predict and replace the spike. One of the stations could be a remote reference so that it will take the advantage of the traditional remote reference MT exploration method. Example of the spike by variance technique for 4 simultaneously recorded MT stations on the right-hand side of the slide. The red line is the original curve while the green line represents noise removed for 114,000 seconds. This slide shows 2 deep wells, HTL No. 1, HTL No. 2. Both drilled in the northeast of Taiwan by geothermal drilling project under the National Energy Program after carrying out different exploration methods. The separation of the 2 wells is about 1.5 kilometers. Well HTL No. 1 was drilled to a depth of 2,200 meters with highest measured temperature of 70 degrees at the bottom of the well. The well did not discharge. Well HTL No. 2 reached to a total depth of 2,800 meters with a maximum measured temperature of 120 degrees at the bottom of the well. HTL2 is quite fractured. It meets an obvious fracture zone between 1,800 meters and 2,300 meters. HTL2 discharged clean water with a flow rate of 130 tons per hour without obvious calcium or silicate precipitation. It is believed that the well intersected a fault, probably the Lanyang River Fault. The low resistivity seems to represent a fault with local alteration on the formation near the surface from the hot fluid. This slide shows our MT array results around the area. It shows no evidence of geothermal reservoir around the 2 wells. In the figure, the effective apparent resistivity is used. The vertical scale is in log 10 frequency. The frequency ranges from 400 to 0.001 Hz. HTL No. 2 is close to a low resistivity zone at the local surface. It may explain why HTL No. 2 is better in temperature and flow rate. There is a low resistivity zone along line A to A' on the surface in a northwest to southeast direction located in the southwest of the drilling sites. The low resistivity seems to represent a fault with local alteration on the formation near the surface from the hot fluid along line A to A'. Now I would like to show our MT array results compared with the drillings at Chipen Hot Spring Resort area in Taidong, east of Taiwan. This slide shows geographic locations of the MT stations, the well and the profile B to B'. This figure represents the well temperature logging data and the temperature profile BB along east-west direction. It could be seen that the temperature from the logging data decreased starting from about 250 meters. The dashed oblate was interpreted as the shallow reservoir for the well-known Chipen Hot Spring Resort. At the right-hand side of the oblate, there is no hot spring resort. The shallow hot water was said to come from Jianchin Fault as shown on the right-hand side of figure. This slide represents the effective apparent resistivity distribution with respect to frequency from the MT array along B to B' profile. The red zone on the upper left of the figure coincides with the location of hot spring reservoir at shallow depth. From the current data, the heat source seems to be very deep and the evidence for the channels between the heat sources and the shallow hot spring reservoir is very weak. More MT survey is suggested and the induction vector could be applied to delineate the channels between the heat source and the shallow hot spring reservoir. MT array survey was carried out in the Datun volcanic area in the northern part of Taiwan. The geographical location of the deep well, CPC Jinshan No. 1, is shown in this slide. This figure shows the effective apparent resistivity distribution with respect to frequency along profile A to A' with interest on CPC Jinshan No. 1 well. From the effective apparent resistivity distribution, there is no low resistivity clay as the capped rock. There is a low resistivity layer, probably represent the alteration zone and represents part of the volcanic neck extended from the crater. This low resistivity layer might also explain the acidic zone from the logging data. Below the alteration zone, there is a neutral high resistive zone. The right-hand side of the profile is high resistive, representing different geological formation. This slide is the temperature profile for well CPC Jinshan No. 1 with respect to depth. One could see the temperature drops from about 350 to 850 meters, representing the cold water injection. It starts to increase again from about 900 meters. Our conclusions. The MT array are used to despite the local noise and enhance the signal-noise ratio. The surveys use effective apparent resistivity with respect to frequency to compare with the drilling results for qualitative interpretation. The results show that the drilled wells are located outside of the delineated possible geothermal reservoir. This could explain why the drilled wells are not successful for geothermal development.